Hello everyone, this video is about recurring decimals part 3. In the first two parts I have explained what the recurring decimal mean and how to convert them into fractions. Now I will be taking two more examples to explain how to convert them into fractions. So the first question is here, convert 0.34 and there is a dot on the top of this 4 and we have to convert it into fraction. Now first step is always you have to represent let x or y or any variable name you can take is equal to 0.34 dot. Now 0.34 dot, here this dot on the 4 means that 4 is the only repeating digit. So I will be writing it 4-5 times and I will consider this is my equation 1. Now the second step is because we have to make the decimal part same, and to make the decimal part same, so what we need to do, we need to move the decimal digits towards the left side. When we have to move the decimal point or the digits to the left side, so what we need to do, we need to multiply the equation by 10 or 100 or 1000 depending upon the given question. So I will first multiplying this equation 1 by 10. So it will be 10x and that is equal to 3.44444 and so on. This is equation 2. When I compare the decimal part of equation 1 and 2, they are not same. So that means I need to times the first equation by 100 you can say, or second equation by 10. So if I multiply this second equation by 10, so it will be 100x because 10 multiplied by 10 is 100. And here the decimal point, the digit 4, it will be moved to towards the left direction. So it will be 34.44444 and so on. Now when I look at this 2 and 3, what you can see here, both the equation 2 and 3, the decimal part is exactly same. Here you can write as many number of 4s, but in the beginning it should be exactly same thing. It should end with same number or a little bit change, but you can make them same because dot means you can put as many 4s here as you want. Once you find the decimal part of two equations same, you can write them down again, like 100x is equal to 34.444 and so on. And that second equation is 10x, that is equal to 3.444. Those who feel like they are very comfortable by subtracting here, they can do that as well. So here if I am subtracting these two, so I will be getting 90x and that is equal to 31, and there is no decimal point, like it's 0.000 basically, so we can drop the decimal point. And now I got the equation 90x is equal to 31. To find out x, I need to divide both sides by 90. So I will be getting x is equal to 31 divided by 90. So this is the final answer for this question. Now second question, I am taking an example is here, and that is prove algebraically 0.512 and there is a dot on the top of both 1 and 2. It can be written as 169 over 330. So same process is there. First is let assume x is equal to 0.5. Now 1, 2 dot means 1 and 2 are repeating again and again. So I will be writing it this way. This is equation 1. Then the same process I will times it by 10, the first equation. So I will be getting 5. The digits will be moved towards left side. 1, 2, 1, 2, 1, 2, 1, 2, 1 dot dot dot. Make sure you move the digits properly and only the repeated digits you have to write. Sometimes students in this point they can mistake like 5.12 and they can write again 512, 512. Then it will be wrong because only 1 and 2 are repeating. 5 should be written only one time. After this, because the decimal part, if I look at these two, that is not same. So I will times this equation 2 now by 10 again. So it will be 100x, 10 multiplied by 10, and here it will be 51.2, 1, 2, 1, 2, 1, 2, 1, 2 and so on. If I look at the three equations, still the decimal parts of any two equations, they are not same. Any of the two equations is not same. So I will again times by 10. So it will be 1000x. You can consider you are multiplying x by 10, x by 100, x by 1000, or you can times second equation by 10, then third equation by 10, and so on. So now I got it 512, and then I got 1, 2, 1, 2, 1, 2, and so on. Now if I look at the equation 2 and equation 4, you have to look each and every equation. It's not like always you have to match with the first equation. You have to match any equation. Like you should match all the equations, whichever having the decimal part same, you can select them. So when I reach up to this point, I found the second equation and fourth equation, they have same decimal part. So I will subtract these two. I will do equation 4 minus equation 2. So it will be 512 dot 1 2 1 2 1 2 and dot dot dot. Second equation is 10x, and that is equals to 5.121212 and dot dot dot. I'm gonna subtract these two equations. So 1000 take away 10, that will be 990x, and this is gonna equal to, the decimal part is going to be 0, so I'm not gonna write anything for that. I will drop the decimal point as well, and here I will be getting 507. Now I got 990x is equal to 507. I will divide both sides by 990. So I am going to get here is x is equal to 507 over 990. Both the numbers are divisible by 3. So I will divide them by 3, and I get here 5 ones are 5, 5 6 are, 3 ones are 3. Then 2 will be the remainder, 3 6 are 18, and 3 9s are 27 over 330. You cannot further divide it, and see, this is what we have to prove. So x is equal to 169 over 330. Similarly, you can get some questions similar to this one, and even you might get the questions like, for example, you can apply the operations also. Let's say you have to solve 0.3 dot minus 0.05 dot. So what are the steps? You have to write it as a fraction using the same strategy as I did for the previous questions. You have to write this also as a fraction, and we know how to solve the two fractions for the subtraction. That's it. Okay. Thank you.